welcome you to our seminar this afternoon. The focus of our discussion today will be mainly to introduce the latest features of our 14.8 release of Semcad. And I'm going to do this firstly in the form of just sort of a generic example that I've set up. This involves sort of the simulation of a broadband loop antenna placed on a dispersive phantom, generic phantom. So this is the example that we're going to look at today. So the phantom could resemble some kind of torso phantom. And what we're going to look at today is actually how we can address conformal modeling. So in this case, I can show you here quickly. We've actually gone and, let's go like that. We've gone and aligned the antenna conformally on the surface of the phantom. So this could be any bent object, could also be sort of a brick or something. So using some sort of PCB molding where you've basically bent the antenna onto your structure. So I think this is a relevant example which will also illustrate several of the new features that we've been working on in this release. Okay, so the first thing that I've done here, I'm just going to start, we'll come back to that model now. This is just basically the parametric ellipse model that we've generated here, which I'm using for the torso, and we can model that with the functions defined here, or cylinder cone. So I've basically generated the phantom in a first step. And now what I'm going to do quickly is just basically introduce the parametric loop antenna. And this we can find, so this is something that we've had for a while, under the MRI system P-loop. So this has just generated another parametric object. The geometry I'm going to increase slightly, so we can make the width about 20, and the height about 35. Millimeters, and I'm going to set the thickness to 0. So we've made basically a surface, metallic surface here. I'm going to increase the strip width for the loop, and then just basically go and increase the chamfer length to about 5 millimeters. So that's just to generate a very simple loop geometry. And now this brings us already to our first modification in terms of features. So I'm sure you've all seen the interactive translation and modeling rotation tools that we have. So the first thing that we have changed now is that it's actually possible to set the resolution during the interactive movements. So now, for example, let's start off with an interactive rotation. As before, we can basically rotate using the mouse, but now instead I'm just going to rotate, by 90 degrees, or we can actually just specify here to rotate around the x-axis. So this is pretty handy. Now I'm going to switch over to the translation functions, and in the beginning I can use a coarse resolution of say about 1 millimeter here, and I'm going to start off basically translating the loop in the Z direction to sort of position it in the center of the torso. You can see, as before, we have the preview actually illustrating how much the translation vector has been moved. But the difference is now, if I want to do fine positioning, I can start off just by sort of moving the loop to approximately where I want it. I'm going to zoom in here a little bit. And now I can actually go and reduce the resolution. I'm setting it to 100 micron now. And can basically now do very fine positioning, but still in an interactive fashion. So this is something that has been changed, which helps a lot. In addition to this, we can actually define offset vectors, as with the other translation tools. So these interactive tool sets now kind of give you a full platform sort of mixture between interactive, but still give you the possibility to do exact modeling at the same time. So that's something that can speed up a lot of the standard modeling operations that you may use. Okay, so the next thing that we're going to look at is how can we actually now go and basically take this loop antenna and basically wrap it onto the torso phantom that we've generated here. And to do that, we're going to use a tool called Project Wire. This is also something new in 14.8, and how that tool works requires basically a polyline or spline definition of the profile that we would like to project onto the structure. So the first step I need to do here is I'm basically going to create two profiles for the inner and outer edges of the loop. And I'm just going to do that using a polyline here. And very quickly here, just basically snap to these corner points with the mouse. So I click the last point again, and now I just press apply. And you see now, this is just, I can just hide the loop quickly. This has generated a standard polyline profile for the loop. I'm going to do the same now for the inside edge, and basically, again, click all of these corners here. And also something that we looked at in the previous seminar that we had is how the new snapping is implemented in 14.6. So you can see as we sort of move along the edge of the loop, the mouse actually recognizes it as an edge, but once we move into the corner, it will snap here for the exact intersection point there. Press apply again, and I can close that tool now. And just to show you then, now we have basically defined these two polylines, which at this point are still aligned basically in the Cartesian plane, so in the XZ plane.